Hello and welcome to the latest Surveytech webinar. This one is all about drones. I'm just going to let everyone file in because I can see we're gaining attendees as we speak. First thing to say is that our guests are going to make a series of presentations, just about 5 to 10 minutes each, and then we will have a Q&A afterwards. You are able to ask questions and they will pop into my box, and then I'll put them to the guests. So hopefully we'll have a fairly lively discussion. With that, I'll bring in our guests. So first of all, joining us from Ireland, we have Colm Hennessy of CHI. Then in Oxfordshire, Rhys and Dan of GWP Consultants. And then down on the coast, the south coast of England, in Dover, we have David Frazer. I'm going to let them introduce themselves. So David, could you maybe tell us about how you came to being a drone pilot? It sounds cool, doesn't it? I'm a drone pilot.
I always enjoy telling people actually that I am a drone pilot. It's the perks of the job. But yeah, so I'm a building surveyor. My degree's in building surveying. Whilst at university, my friends and I were in video production, and to get some extra beer money, we used to film everything. And one day, one of the guys was like, "Oh look, I've got this drone," which was like a Phantom 1 before they'd even put cameras on the drones, and we ended up gaffer taping an iPhone to it. And yeah, throughout the years, we were like, "This is pretty cool." Ended up working at the Port of Dover as a building surveyor. Whilst on the project, there was a need for stockpile surveys, orthomosaics, that kind of thing, and we set the business up, and yeah, so that was 2017, and we've been going from strength to strength ever since.
And I mean, obviously the whole drone sector, every week we're kind of finding out new applications, and you know, we're certainly going to get into them later. So our second guest is Colm Hennessy, who I met when he was working as for a drone supplier, because he was the product manager for DJI drones at CMS Distribution. So that's how he came onto my radar, and now you've got your own drone company, Colm.
I do. Thanks, Matt. So I got into drones back in 2016, maybe 17. Kind of just as a hobby, I guess, and started doing a little bit of freelancing and taking photos for likes of auctioneers and construction companies and things like that. Over the years, I worked within the licensing side of things. So I worked with a company called Fly Right Drone Academy, for about a year and a half, 2 years, issuing all the licensing. I also worked with a reseller over here called DroneWorks Ireland. So they're a large kind of drones supplier over here, of consumer and enterprise drones. And then more recently, as Matt said, I worked with a company called CMS Distribution. So we distributed all the drones to the UK, Ireland, and Benelux. So my responsibility was to buy them directly from China, and then keep them in stock and sell them to the trusted resellers across the UK, Ireland, and Matt, yourself, was one of them. So I pretty much had a day-to-day link with DJI, kind of spoke to them daily, and had a good relationship with them. Yeah, so that's me. It brought me up to about maybe 2 months ago, and decided I was going to go back out on my own and start CHI again.
Excellent. So yeah, it's going to be great to hear your experience and maybe get into a bit of the different aspects of the DJI range that we obviously offer at Surveytech. And one of the customers who have availed of that DJI range is GWP Consultants in Oxfordshire. So we've got Rhys Morgans and Dan Watkins. So Rhys and Dan, can you tell us about your about GWP and your experience coming to drones?
So yeah, we got into it fairly early on through a contractor back in about 2012. We met him at a Quarry Expo. It promised an awful lot. We were a little bit skeptical at the time, thinking, no, it can't replace what we do. We trialed it and we were really impressed. It lends itself really well to, you know, large scale quarries and earthworks projects. Sort of built until we had our own sort of self-sustaining workload in about 2016. We thought we've got to make the jump into this ourselves. So it was rather by accident, but it's been great. It's given us, you know, new challenges and sort of taken us in different directions than we may have gone in otherwise. And whereas at the start it was probably 10% of our workload, it's now probably 85–90% of our workload is conducted with drones. So in that relatively short space of time between sort of, you know, 2012 right till now, it's really taken over. So it's great.
That's extraordinary. So we're going to go straight into your presentation. I'm just going to make you the presenter now. But the fact that you know, just whilst you were working there, it's changed that much is amazing. And I guess quarries are one of the best examples, because there are certain places that it's better for people not to be walking around, and it'd be better to have a drone. So it makes sense.
We'll touch on the safety benefits in the presentation, but that is one of the huge advantages of the drone tech in our sector. It's the coverage, the resolution, but the safety benefits, and that's one of the things, you know, we don't feel that the drones really get pushed enough on. They get kind of a bad name in some, you know, aviation circles, but the day-to-day safety benefits can't be ignored in our view.
Yeah, 100%. All right, thanks. Well, I'm looking forward to seeing your presentation, and that photo really, every time I see it I think, wow, what a stunning vista.
That's the one we kind of fight over this site. It's down on the coast in Cornwall, but yeah, fantastic site, and it makes all those horrible winter days worthwhile. So yeah, well, we'll dive into it then if you're happy, Matt. So thank you first for inviting us to give the presentation, Matt. We're going to touch on how we've been using UAVs at GWP over the years, the benefits that they brought to us as a company and our clients in terms of the data we can collect, and what we're able to do with the data to provide many of the specialist services that we offer to our clients. And like we say, yeah, we've included this image on the front because we think it's brilliant, and it was taken with a UAV, so it's definitely relevant.
At GWP Consultants, our core business is based around the mineral extraction industries, both national and internationally. As a surveying department, we service that core business whilst also operating in much the same way as other survey companies, conducting surveys across the architecture, engineering, construction industries, as well as for private individuals.
So like we said at the start, in 2012, we paired up with a contractor who was just offering traditional, you know, Nadia mapping services using an EB. We were skeptical about the quoted accuracies. We'd heard quotes of around 100 mil vertical accuracies. So we decided to run some trials alongside our traditional data, and we were surprised with the results we were getting. After 4 years of using the contractor, we decided that we had the workload to support the technology, and we required that flexibility of our own UAV solution.
So we trialled several platforms to find the most suitable, and settled initially with the Quest Datahawk. It was well suited to large-scale quarries, landfills, and earthwork projects, but lacked ability required for some smaller jobs that we were doing. It required a bungee system for launch, as you can see in the video clip. The benefits to this platform were the large areas we could cover, and the large payload that we were able to carry.
We then moved on to the unique H520, with the hexacopter. We went for this platform because it had the 6 props, so you had the stability, fully retractable legs, so you didn't get the legs obscuring any of the imagery. Fully gimbal payload that was also able to be hot swapped. So there was a thermal option, there was an inspection camera, and the E90 that we used as the mapping camera. When we took this on as well, we looked at it was marketed as a commercial platform as opposed to the hobbyist drones at the time, that was a sector we wanted to be in, and it gave us the flexibility to undertake our normal nadir mapping, but we could also play about with the oblique imagery, and this is where we sort of started to cut our teeth on the face mapping, purely by accident, starting to take some oblique imagery of the quarry faces, see if it would process in much the same way as the nadir mapping would, and we sort of developed the workflow with that, and that's now become, we'll touch on it later in the slideshow, but it's become useful for geotech and geology departments to different rock mass characteristics. We used 4 of these platforms, and we ran them for about 5 years, so they were a real workhorse.
So we're currently working with the DJI Mavic 3E. Some of the benefits are, because it's smaller, it allows us to be very mobile on site. It's got great observance when we're some of the older platforms, which is very useful for the low altitude flying, like our face mapping. There's lots of technical advancement with the camera, shutter speeds, increased flight speeds, battery life, and you've got RTK corrections. The RTK corrections are configured to run from a network source, but where available due to phone signal. In some of the remote areas we operate, it's not always available. So we've also configured our Geomax Zenith 60 antenna to send corrections via an N-trip connection, which gives us coverage anywhere we need it now. And the overall benefits of drone solutions within our sector is large-scale, high-resolution data acquisition, reduced exposure to hazardous areas by increasing data capture. So we're now able to get data in rock traps and working areas and plant areas, as well as quarry faces. No longer have to expose personnel to high traffic areas, and movement around site is limited and more predictable, and we limit interference from magnetic and radio output.
So we mentioned earlier about face mapping that we undertake. So by turning the camera to a B camera, we can quarry faces mapped in much the same way we do mapping. We developed quite a workflow to be able to do this. But now we can record joint parts, dip directions, dip angle, joint placement, and distance, as you can see in that. The data acquisition is faster, and the geotech engineers now identify what mass features from the safety of the office. The data sets are much more complete, including for example, if it's 2 geotech previously, 1 week to rock mass allows you to quarry. And whilst they're doing this, they're exposed beneath the quarry faces for long duration. So it comes to it's a dangerous spot to be in. Whereas now we can do that project by 1 person in 2 days, and you're removing that person from the danger area entirely. So it's been a great addition to our outputs to deliver for the client.
We're also using drone data for 3D rockfall analysis. Once again, this is a much safer, more complete method of data acquisition. The block face geometry is very accurate. Block sizes and shapes can be identified, allowing for more accurate calibration of the actual rockfall model. And it allows for checks on rockfall protection measures and aids in the design of potential solutions. In the case of the example shown, the of the haul road was required to complete the work safely.
Like I mentioned earlier, we still do the traditional sort of nadir mapping, usually for sort of design of earthworks, cut and fill volumes, stockpile volumes. Most of it we service the sort of core business of GWP, whilst also working for other clients as a survey department ourselves. So our work is for the quarry and earthwork sector. We also do a lot for golf courses. And then these 3D models we use to facilitate earthwork design or for machine guidance. The topographic surveys we tend to do in conjunction with other survey techniques. So the workflows we developed at GWP, we don't rely on any one technique. We look at it as each method has its own strengths and weaknesses. I know, drones are a holy grail. We think it's an excellent tool. And when someone comes to us, we'll tend to pick the most suitable combination, usually based on the site, the required deliverables, and the specification. That brings us to the end of our presentation. So thank you very much for listening, everybody, and we'll take any questions in the Q&A at the end.
That's great, thanks. There's been a slight bit of distortion in the sound, but I think it was really fleeting. But I think we got all of it. Yeah, it's really great to see, how you've developed and kept adding strings to your bow and alongside your core competencies. So that was really interesting, guys. I'm sure we'll get into it in the Q&A. But for now, I'll make Colm presenter, and we can hear what he's been up to in the central heartlands of Ireland.
Thanks, Matt. Can you see my screen okay?
Yeah, I can.
Perfect. Thanks very much. Thanks, Matt, and thanks, Rhys and Dan as well. Very good presentation. So what I'd like to do is, I suppose today I'm going to speak about the drone applications in different types of industries. So the chances are, if you have a drone or thinking about buying a drone and doing work with it, the chances are the work you're going to do is going to fall into one of these industries. So what I want to do today is kind of just give a couple of different examples of how drones are used in these different types of industries. So I suppose the first one, public safety. So in public safety, I suppose search and rescue missions. So drones are equipped with the likes of thermal cameras, night vision cameras, speakers, and various different types of sensors that can help locate missing people to find them in difficult to reach areas. There is a website, enterprise.dji.com/drone rescue map, and that gives you kind of an interactive map of the world, and it shows examples of where drones have been used to help, I suppose, save people's lives or help aid people to save people's lives. I think the number on it is like 800 or 900, but the chances are it's probably way more than that, because they're not necessarily always recorded. Another example is crowd monitoring control. So drones can provide aerial surveillance and assist in monitoring crowds during large-scale events or protests. So an example actually is, over the weekend here in Ireland, we had our version of Glastonbury. It's called Electric Picnic, and there's a company, I actually know the guys quite well, Aerial.ie, and they provided a lot of kind of drone footage throughout the weekend, and they were like the official partners of the event. But there was one stage in particular, or one arena in particular, that was way more crowded than they actually expected, but the police was able to use that drone footage to realize, okay, we got to stop letting people in here. So just a kind of example of where it's useful in crowd monitoring, and also disaster response. So drones can be used to assess damage after, let's say, a natural disaster or any other emergencies, and provide real-time imagery and data to the likes of first responders. So just a couple of examples of public safety, how drones are used. The likes of the Matrice 30T, any of the thermal cameras really would be really useful within the public safety area. And then also the likes of the Matrice 30T, it's got an IP rating of 55, so that means like it can be in really harsh weather conditions. Not supposed to be flying in rain, but sometimes you have no choice, and in really harsh conditions you're able to fly the drone in really bad weather. Likes of AEC and surveying, so Rhys and Dan at GWV, some really good examples of where drones can be used here, and I know David up next will have the same. But in terms of site surveying and mapping, drones can be used for aerial images for construction sites, and generate accurate 2D maps, 3D maps, which can be used to help plan construction and monitor site progress throughout a project or throughout a build. Inspection of buildings and infrastructure is another one as well. Drones can be used to inspect buildings, bridges, any other, I suppose, kind of big structures, reducing the need for manual inspection, and that in turn improves safety. DGI say that a typical 15-story building takes 128 man-hours to inspect. That includes the likes of getting scaffolding up, getting people inspect the building, taking scaffolding down, but using a drone. You might have two people, you might have a drone pilot, and you might have a spotter as well. It takes about 16 hours. And then survey for land development as well. So drones can be used to survey large tracts of land for potential development, and providing detailed information about the likes of topography, drainage, vegetation, and various different things. The likes of electricity, China Power Grid is an example here of someone or a business, I suppose, that adopted drones. They adopted drones back in 2018. They inspect on average 242,000 kilometers of power lines per year. That's 15 times their capabilities the year before they used drones. So obviously they're able to, that's really useful there. They can be used to power line inspections, other electrical infrastructure. This just reduces the need for manual inspections as well, and in turn improves the safety of their workers as well. The next two examples, solar panel inspection and wind turbine inspection, I suppose these are kind of really kind of, I suppose, newer kind of ways or different ways that we can use drones. The likes of solar panels can inspect the likes of damage or any other issues, and just help identify problems early, and reduces the requirement for maintenance further down the lines. And exactly the same with wind turbine inspection, identify damages, wear and tear, or anything like that, where drones are really useful as well. Next example is oil and gas. So drones can be used to inspect pipelines for the likes of leaks, corrosion, or any other issues like that. The massive oil and gas company Shell, they've got their own fleet of drones for monitoring this every day of the week, and they're able to cover hundreds of kilometers daily of different types of pipeline. Offshore rig inspection is another one as well, where drones are used to identify any wear and tear that may require maintenance, and also environmental monitoring. So drones can be used to detect oil spills and any other environmental issues, providing real-time data response and helping to mitigate, I suppose, an impact of any disaster, I suppose. The last one then is agriculture. I suppose the main one and the obvious one is the precision spraying and using drones to spray crops and look after crops, but crop monitoring is another one as well. Can be used to monitor the health of the crop, the growth of the crop. This provides farmers with information on plant health, nutrient deficiencies, and irrigation needs, and things like that. And then the last one, another real obvious one as well, is livestock monitoring. So I suppose, for example, if you're a farmer and you've got a fairly, let's say, substantial amount of acres of farm, and instead of driving the tractor down or driving a quad down or whatever, you can use a quad to check on your livestock as well. So they're the kind of main different industries. If you have a drone, most likely what you do is going to fall into one of those industries. So I wanted to kind of just provide a very quick overview of the different industries in a small amount of time. Yeah, I suppose another thing I wanted to talk about was quickly about my own company, CHI. So my company will specialize in two different areas. One is going to be very much drone inspection, surveying. Within the construction industry, site monitoring, progress inspection, data collection, project development, and things like that. And then the other half of it is going to be very much property media services. And I suppose the reason I'm bringing this up is because I found a really good example of, and I know Matt would be very interested in this, of where you can use the likes of a Matterport with drones. So if you bear with me till I just find it super quick. And it's actually it's a video from about 3 years ago, but it's just using the likes of a Matterport and a drone. It's just a really good example of how both can be used. So obviously that's the drone flying around the house right now, and then it starts incorporating the Matterport. Obviously it takes a lot of video skills and things like that, but there you can see the Matterport virtual tour in through the roof as well. And it's just a really another good use case for drones and what they can do, and a plug for you, Matt, on Matterport. And that's me.
Thanks, Colm. Obviously, I'm always pleased when we get cross-pollinations of different technologies that we provide, and obviously it feeds in massively into the whole concept of the digital twin, and the drone is really you know, an essential tool for that, because it gives us the aerial viewpoint that you know, someone on the ground with a scanner would really struggle to get. So I think we'll crack straight on and make David the presenter, and he can tell us exactly about how that viewpoint might be used.
Yeah, so thank you. First of all, can you all see my screen? I just want to make sure that that's...
Yes, yeah, absolutely.
Okay, perfect, thank you. Yeah, no, thank you, Matt, for the introduction, and thanks to the other presentations, guys. I'm David, one of the directors of Cloudcam. We're an aerial surveying and video production company, but we specialise in 3D modelling and digital twin acquisition. Basically, we basically offer every service you can do with drones other than agriculture, but we're kind of becoming more of a specialist kind of heritage kind of construction kind of outfit. So to start with, I was going to talk a little bit about flight restrictions. So predominantly, where is it possible to fly? I get asked this question probably every single day. Now, the loose kind of answer to that is that you can theoretically fly anywhere. You just have to have the paperwork and the permission to back it up. So in the bottom left there of the screen is it's a photo taken from Drone Assist, which is an app that I'm sure that most drone pilots will now be using. But this basically gives you a map of all the permanent and temporary restrictions that are in place. Now, obviously, this area is London. It's very congested in terms of the restrictions that are there, but you can from that, you can basically identify. You can click into it, and it will tell you what areas are actually highlighted and that kind of thing. And then, so dependent on what the restriction is in place, for each job, we'll assess it and work out whether we want to what type of actual drone to use. You'll hear sub 250 a lot. Now, the 250 gram kind of rule makes it a lot easier to fly a drone. The permissions are a little bit more laxed. This is all UK based as well. I know it's different from country to country. The permissions are a little bit more lax. Now, there is a drone code that you still need to follow, but using a sub 250 grams drone is much easier to carry out, say, visual inspections and that kind of thing. However, if you're wanting a much more sophisticated kind of survey, such as 3D modeling, topographical surveys, that kind of thing, you're going to be using a higher weight drone, which then has a knock-on effect in terms of your permissions and the flight packs that you need to provide and to actually be able to allow to fly in the area. But yeah, overall, you can theoretically fly anywhere. You just have to have the paperwork. So I was going to go through a couple case studies of kind of the outputs that we actually offer as a company. Now, topographical surveys is probably one of our biggest outputs. This can be generated by either photogrammetry or Lidar payloads. Photogrammetry is a scanning system, I guess, taken up of lots of photo points, whereas a LiDAR is a laser that's scanning millions of points at one time. The benefits probably a LiDAR over photogrammetry is that LiDAR can penetrate some foliage. However, photogrammetry is probably a much more cost-effective kind of option. In terms of accuracies, they're pretty much near on there now. But they give you ultimately the same kind of end result. So topographical surveys, what we typically use is ground control points, or GCPs. These are targets that are placed onto the ground, which have a GPS coordinate built into them. These are either taken by, say, like an RTK rover type system, or the ground control points that we actually use have a GPS unit built into them. The benefit of using the GPS units built into the GCPs is basically you're able to leave the target out for a much longer period of time, which means your accuracy of that position is going to be more accurate. If you're using a staff, you're probably only going to be there for 5 to 10 minutes, whereas with the actual built-in system, you could be there for a couple of hours, and it's just going to give you that much more accurate lock. And then when we actually process the data, it makes it tie much more accurately. So with drone surveys, as opposed to traditional methods, the time on site is significantly reduced, but the accuracy arguably is actually higher. You can cover a much greater area of site quicker than walking around with the staff. The other thing is that a surveyor will only measure every few meters, whereas the drone is physically scanning everything. So if you need a particular height of a particular point, the land surveyor may actually miss that piece area that you want, and it's then taken as an average across 2 points, whereas this is literally effectively giving you that scan point at that exact location. And then once all that data has obviously been collected, we then process it into a 3D model. That 3D model is then converted into a CAD model, and then that is then shared with the client. What I will just show you, so this is an example of one of the 3D models. Hopefully this plays, so please shout if it doesn't. But this is actually one of our mesh models of the topographical site for this particular site. It's quite heavily with foliage around the perimeter. It's a standard greenfield kind of site located in an urban surround. And then this is the output. So the top left image there is the orthomosaic, which is effectively a Google Earth image that we've generated, overlaid with the topographical survey. And then you've got a clear representation of obviously actually what features are on the ground with a photorealistic image over the top. And then to the right of that is just your standard topo kind of image. Moving on to kind of 3D model acquisition. This is the Admiralty Pier Lighthouse down at the Port of Dover. We were asked to actually go carry out a survey of the entirety of the pier and the lighthouse for a new radar mast that's being installed. Traditionally speaking, to survey this, it probably would have been carried out by boat. Now, to carry out a photogrammetry or Lidar survey from a vessel to cover the top of the lighthouse is quite challenging, especially with the position of this particular pier. It's surrounded by water. Obviously, the water's lively. It's having a big impact on the stability of the boat, which then has a knock-on effect on the actual accuracy of the data that you're generating. To also carry out a survey of this kind of size, again, you're going to be talking probably a day, if not two. We were able to actually carry out the scan in a matter of hours. And then we were able to generate the same kind of outputs as a topographical survey. So again, a full 3D model, a CAD model that goes with that. But the model was actually accurate enough to be able to measure the mortar joints between the blockwork. So the image on the top is basically just a site image of the lighthouse itself, but below you can see the CAD 2D plan that was made from that, and then with the author over the top. And then this should be, yeah, this is the 3D model. Now, what you do find with surveys surrounded by water, you get a lot of kind of erroneous points that form, and that's purely because the water's moving. So if you actually look around the base, there's some loose points. Now, we typically clean that up as best as we can, purely because you want the most accurate model. But obviously, with the tide going up and down, with the waves and that kind of thing, the scan data can come a little bit confused. So we clean the model as best we can, and then that gives you the best kind of output. So then taking 3D modeling to one step further, we realized a few years ago that the camera itself on the drone can be used both internally and externally. Although we do fly the drone inside, sometimes it's exactly the same parameters, but you can then create the same kind of model and then stitch them together, similar to what Colm was saying about the whole Matterport integration with the drone. The crane on the left there is a really high-res model. The plan for this was actually so there was only ever 2 cranes of this type made, from my understanding. Historical drawings weren't quite there, and there was an issue with the pivoting position underneath it. So we were appointed to actually carry out a full 3D model creation, and then so the construction engineer could actually dissect the model, work out which cog goes where, how it actually works, and was able to then actually work out how to diagnose the repair. And then it can be used again. So there's a historic clock tower to the right, and the building to the bottom is the port control building down in Dover. And then here I will just end on a short video of a couple of other examples. So this was an archaeological dig, a Saxon burial mound. All these models are highly to scale, so you can actually work out cracks that have happened, say, in the skull, to work out possibly cause of death. You can model actual finds position. In archaeology itself, it's really difficult to map each individual point, and we're just zooming into some beads now from a necklace. Now, as soon as someone goes in there and moves that position has been lost. So to be able to scan it in place as you're working is really, really important. This is a shipwreck. It's really useful for emergency kind of recording. Say there's an accident and you need to identify exact positions, what's happening. You can work out the ground around it. And again, this is a survey pit, a services pit. There was a HV cable running from to the new chamber there, round to the corner, and we were asked to come and scan this before they backfilled it, just so they could get a core log of the actual cable position before being backfilled. And then this is just an example of a 3D model of a school that we were asked to generate. We were actually there to film promotional video in progress over the time, and then this was used as part of the as-built kind of handover procedure. So yeah, sorry, that video was a little bit quicker than I was anticipating, but yeah, thank you for listening, and hopefully you might have some questions.
That's great. Thanks a lot, David. I think one thing that everyone is kind of touched on is that the integration of imagery and positioning, which I think is you know, Rhys, you were kind of saying that you almost viewed them as separately. You would do your survey, and the drone might get some pictures, but they're kind of no longer separate, are they? With the advent of digital twins and 3D modeling, you're kind of killing 2 birds with 1 drone. So yeah. Sorry, go on.
We found it, we found that the 3D data is, you know, initially where we were heading, but then the feedback from our clients was that the imagery had equal value, if not more in some cases, than the 3D data. And then the two in combo is great, but it was almost a byproduct that we were sort of neglecting. But yeah, it's definitely become a lot more requested by the clients. So it's,
what's really nice about it as well is the fact that once you've actually been to site and you've scanned the site, you've got the data. It doesn't matter if you want to process, say, a 3D model straight away, or whether you just want the orthomosaic. You've got that data. You can then reprocess it at a later date, and it's actually really useful sometimes to be able to compare from visit to visit. Especially, I mean, say there's a rockfall in a quarry or something that's not been picked up before. You can actually work out how it kind of almost how it's happened in the past by comparing the survey data. So it's a really useful tool to be able to monitor, but do additional monitoring even after an accident's happened, because you've got that base data.
Mm. And your archaeology example was quite interesting. I actually did an archaeology course over lockdown.
Oh, wow.
Because I know how to live, and did a lot of work on aerial perspectives to it, just to keep it relevant for my work at Surveytech. And one of the things I found quite interesting is the massive archive of aerial photography that actually the UK does have. You know, it's it was in the 19th century that some guy got a balloon and took a picture of Stonehenge. So, you know, from then onwards, we've got especially sort of sites of interest. And I wonder if that's something you've looked at with your Port of Dover work, because
yes, it's quite interesting. So we've been down at the Port of Dover now, coming up to, it was 2017 that we started flying down here. And we've worked out, we've probably surveyed about 56 3D models and orthomosaics over that period of time, and since 2017. So something that we're now actually trying to put together is a kind of almost like a layered history map, so a timeline, but that you can compare from point A to point B. But then not only include the data that we've got, but from historical maps and photos, actually we have to then stitch that on top of it. It's, for archaeology especially, it's really useful to be able to compare obviously what was in the past. It can save a lot of time on site if you're, rather than having to do investigative digging, you know, you've already got an area that you say, right, we know there was a building there at some point. So in terms of time and cost on site, it can be a massive saving.
And actually, Colm, in Ireland, back in the Celtic Tiger days, the archaeology was flush with money, and they sent helicopters up with laser scanners to find all sorts of sites. But one thing about drones is that the sort of cost to entry to do that sort of thing is massively reduced. You know, the helicopter with the laser scanner costs an unbelievable amount. And, you know, with the best will in the world, a lot of heritage organizations do not have that money. So, yeah, with, you know, as we were discussing, you can kind of see that stuff through the vegetation. I wonder if you've seen any heritage projects in you'd like to speak about, Colm.
Well, I was just going to say the example about, like, years ago, people using helicopters and planes, because as funnily enough, I was just chatting to a guy yesterday, Tom is his name, and he like 10, 15, 20 years ago, it would have been him going up on the planes, taking the photos, taking the videos, and doing everything like that. And ironically enough, that's actually one of the reasons I got into drones, because in Ireland, in your typical kind of farmhouse over here in Ireland, there's a good chance you're going to have a photograph from the plane from about 15, 20 years ago. And there's one in particular at home that I just grew up always admiring and always liking, and I couldn't wait for the airplane man to come back around again and retake the photo. But unfortunately he never came, so I ended up having to buy a drone and do it myself. But the cost to actually go and do that back then, like, that man would have been taking probably hundreds of photos and going around and selling them to individual houses, whereas now you can buy a Mini 3 Pro for £600–700 or whatever it is. So the cost of entry is much cheaper than it used to be.
With the proviso that especially the companies that will have tuning in will need to have the public liability insurance, and as David showed in his presentation, a very solid awareness of where they can and can't fly. The first question that came in, I think, was probably for Rhys and Dan, was how I mean, it definitely was. How did you do the rockfall analysis before the drone?
It would have been done simply by the measurements that could be reached by the geotech engineer, so a compass clinometer. We did have a photogrammetric piece of software called Blastmetrics that could take stereo pairs of photographs, but you were kind of quite limited on how much of the quarry face then you could do. Whereas now we might throw, the one quarry we threw 3,000 images at it, whereas using the old system they might go out and take 20 pairs of photographs. So all of a sudden, you rather than focusing in on certain areas of the quarry, you're able to get whole quarries, so they can see if joint sets are persistent in one face, do they then pop up in another area in the quarry, and that can sort of help the design. But having the geotech engineer up against these quarry faces for long durations, one, they could only access the data they could physically reach and get at, and obviously there's the safety implication that comes with it as well. So the drones kind of address both of those issues and just push it onto another level.
Yeah, I think both your presentation and David, that your maritime example, I mean, if you wanted to get close up to that wall, it's not the greatest idea when choppy seas or whatever.
No, exactly. I mean, that particular survey, the one side of that key wall is actually in the English Channel, and it's probably one of the most exposed locations. So you're probably going to get such a small window of opportunity to scan something of that kind of size. But with the drone, so long as you're within your wind parameters, you can pretty much do it whenever.
And I think that really was something that fed through in all the presentations, is that not only can you'll capture everything it can see up there, but it just gives you the opportunity to take advantage of, there's certain things like house surveys where if you had to get ladders, you had to clear areas, cherry pickers, that sort of thing. It's all just time and money that you're spending when a drone would be a sort of a simpler route to it. And the same with the earthworks surveys. I mean, even having a surveyor walk around on top of the mounds, it's just a lot of time, and you can create a full digital model of an appropriate accuracy without having to take on those manual tasks. Rhys, did you have something?
Yeah. So it's relevant to the previous point there. So we map a chalk face down in East Sussex and Lewes for an insurance company, and prior to using drones, it was done with the largest cherry picker in the UK, which was also used for the cricket and the golf as well for filming. So there was a narrow window of opportunity where you could use this cherry picker. It couldn't be used in certain wind conditions. Obviously, you have to put two guys up in the basket as well, so there's a risk there. And it was done over, I think it was 2.5 days, whereas now within a day it's done safely with the drone, and arguably the data set is better quality as well.
Yeah, I think obviously the safety aspect is always the most important thing, and whenever there's a new technology or something, I think that should be at the heart of of how we want to work going forward. You know, if it doesn't if it doesn't improve safety, then the benefits aren't quite as good as they could be. So there was one question about what are the different payloads you've used? So David, I think you've probably had quite a bit of a variety, because there's so many, you know, multispectral, great for identifying tree types.
It's, I mean, it's trying to use the right tool for the right job. So our primary survey drone is a Matrice 300, which is DJI's. Well, to be fair, they've just obviously released the 350. So that can actually take up to 3 payloads at one time. And I mean, traditionally, the actual reason for the drone was much more for like a search and rescue kind of setup. So you'd have, say, a thermal imaging camera on there, a speaker and a spotlight. But actually, they suddenly quite quickly realised that the thermal imaging camera could be used for, say, solar inspections. The zoom capability on the H20 and the H20T camera it's ridiculous. I mean, we've been doing surveys. You're probably about 100, 150 meters away from a tower. You're able to zoom in and read the writing on the bolts holding it together. So to be able to get that clarity without being too close is really useful. But then at the same time, using smaller drones, so like a Mavic 3 Enterprise and that kind of thing, being able to get up close to the building to get a higher res kind of image and from a different kind of perspective is really useful. I mean, for the photogrammetry kind of side, we run a DJI P1. It's got a really high shutter rate. The focus is absolutely incredible on it, and it means that you can carry out, I think they quoted on their website that you can do, it's like 180 acres in I can't remember now, it was 30 minutes or something ridiculous, or 3 hours or something ridiculous. So the actual time that you're able to scan with a camera that's able to cope with the speed that you're flying, obviously reduces your survey time, means you can cover a greater area, but still at high accuracy. And then there's obviously the whole Lidar division. There's hundreds of different payloads in Lidar. The only thing I will say about Lidar, we've tried multiple different kind of cameras from DJI directly to third party. Some of them aren't quite as cracked up as what they say they are, especially with vegetation. It's taken a while. I mean, I have to admit that the DJI L1 sensor, it's as a sensor that's off the shelf, if you like. It's a really useful, quick and simple kind of tool to use. But there are other sensors then out there that cost an absolute fortune, but they'll give you a much higher grade accuracy. So it's kind of finding that balance of, as I said, what tool is right for the job that you're actually doing at the time you're doing it.
Yeah, and it's useful to sort of point out that not all drones and payloads are created equally. So, you know, your Mini 3 Pro is a fantastic tool. It's a light drone, but you know, if you can't really use it for topo surveys. It's all down to the jellification effect that happens, and having a mechanical shutter means that the Mavic 3 Enterprise is pretty much your entry level for getting accurate topography. And it's all the sort of thing that we can always discuss with a client when they're thinking about what to use. And actually, it's great to hear your sort of first-hand experience, David. You know, without a sort of salesman telling you this is what you want.
Yeah, I mean, it takes a lot of trial and error to find the right sensor for the actual job that you're doing it for. But you quite quickly work out actually, and it is the biggest thing that we find is actually always ask the client first to what level they need, because there's no point in charging a client for a really high-end Lidar scan if they actually just want some photos of their roof. You're going to lose work, you're not going to gain any more, and you've just paid a lot of money to either hire or buy a really fancy piece of equipment that's just going to sit on the shelf. So that's actually a really kind of key thing to know, is that just make sure the brief is relevant to the drone that you're using.
And you know, with a decent with a good good drone like the Mavic 3 Enterprise, it's amazing what you can do with photogrammetry. And as Rhys and Dan showed with their base, and you with your ground control points, you can actually tie that to the national grid and have everything referenced. And that means that then if a surveyor has to come out with a GNSS rover, they're straight in national grid. If you have to load it into machine control, it's already in that format. And I think that sort of interplay between the different technologies, if you're working through the same you're singing from the same hymn sheet there, which is a really useful aspect. So the last question was, what's the weirdest drone job you've had? I mean, should we, Colm, you must have supported some customers with interesting choices. We were once discussing a pest control application of scaring away pigeons with a Mavic 3 Enterprise with a speaker on top.
Yeah, I'm kind of putting a spot there. But to be honest, Matt, that was probably one of the better ones. I'm not gonna lie. It's very difficult to think of one. Yeah, I'll have a little think for a minute. I don't know.
Okay. Yeah. We might come back to you. David, I'll put you on the spot.
Yeah, thank you. I mean, the one that comes to mind, and we didn't even end up using a drone for it because it was just so ridiculous. But it was a domestic house, some like Edwardian house that had a chimney that had an internal collapse, and they were like, "Oh, can you just stick a drone up there to have a look at it?" I mean, the access hole in the flue itself was probably it was so small that it was just ridiculous. We ended actually using a 360 camera on some drainage rods that we were able to work it out from that. But that was probably one of the weirder kind of questions.
Well, it's a good point. Sometimes the drone isn't the appropriate bit of tech. Although they've been coming on a lot in terms of internal flights and things like that. When I was up supporting a customer at the Silvertown Tunnel, they were flying a drone in through there, and with the appropriate propeller guards and a good pilot, it's a safe and sensible thing to do. Rhys, Dan, have you
couple that jumped to mind actually, weirdly, but one lot is we've done an awful lot with Zip World up in North Wales and the zip lines. So looking at the the stability of faces where they're going to attach these zip lines to. I think Dan, you had a ride, didn't you? You got a free ride on.
Got some free rides on some of the things up there.
But yeah, we also the job wasn't weird, but the client was certainly different. But we can't say who he was because we signed a non-disclosure. But he bought a number 7 shirt for England for quite early. He's got a very posh wife. That was a rather different job, especially when we tripped the security and some sort of ex-special forces dude came up and wondered what we were doing around there. So that was a different job. But I think the Zip World stuff is probably one of those sort of slightly left of field jobs that you're not quite expecting, but interesting.
Yeah, and it's also probably a good example of how drones can be used for so well for promotional purposes, and even that internal drone example, I've seen it used in sort of stadiums and stuff where you're walking through and then suddenly you go up into the air. The sort of cinematography you can do with drones is really remarkable. So any more, or should we close it off there? I think that was a good one to finish on. So with that, I'd like to thank Colm Hennessy, David Frazer, Rhys Morgans and Dan Watkins for joining me on this webinar. Our next one, I think actually we will probably be drilling down into a bit of thermal imagery, so drones might feature with that, and inspection cameras and things like that. So watch this space, sign up for the next one, and thank you to my guest speakers, and thank you to everyone for watching. Have a great day. Enjoy the sun.
Cheers.
Cheers.
Thank you very much.
I know.